Let's begin, I think. Let's begin then. Hello, everyone. I'm sorry we made you a little. We made you wait a little bit. Sorry for that. First, thank you for coming to this webinar and really welcome. We are really happy to have you today. This webinar is the third of a series we have developed under the LFAI and data umbrella within a work group dedicated to trusted AI. Just some small bits of history. I'm not going to be long because I want you to have enough time to look at the presentation. We started with identifying and defining a set of principles around trust for AI. In parallel, we have another group who works on the tools and who continue to work on the tools that are going to be referenced in our landscape. And then after that, we identified some use cases that illustrate the necessity to address the trust question when it comes to AI. So we are now at the heart of the problematic about how to bind principles, tools, and techniques to make it concrete and operational. So this is today's webinar. We are going to focus more on tools and technique. Let me welcome Leila Lee from COSA, Sarah Luger from Orange, Sri Krishnanmurthy from Quant University, and Animesh Singh from IBM, and François Jezekiel from Orange. About the webinar, just a small word. Feel free to ask any question in the chat. We will answer either during the session or at the end. And if we don't have enough time, we promise to answer after. And now I will leave the floor to Leila, Sarah, Sri, Animesh, and François. Just a small comment. For the sake of time, please stick to the timing as we just have 1 hour. So Sarah and Leila, I will leave you the floor to give some overview about the repeats principles.
Great. So yeah, so I guess we're starting to start off with the list of trusted AI principles that's developed by LFAI. And so my name is Leila. I'm the co-founder and CEO of COSA AI. We develop software solutions to operationalize trusted AI principles. And Sarah here is a NLP expert at Orange. I think she is having maybe a little audio issues today. So
can you hear me now?
Oh, yay, Sarah, you're there.
Yay, yeah, I'm here. Great. Nothing like a computer switch. Hi, thank you, Leila. I am Dr. Sarah Luger at Orange Silicon Valley. I work on responsible AI, NLP for call center technology, and low resource machine translation for African native languages. Leila and I are going to introduce this first little section. We can quickly go through the first slides while my colleague will do a deeper dive with a couple examples. So next slide. Excellent. The 8 LFAI principles for trusted AI are listed here. The principles are of equal importance. They're all interrelated and interconnected, but I'll just go through them individually. Next slide. Reproducibility. This is about reliability. The next one is robustness, which is really about stability, resilience, and performance. The following one is equitability, which is to focus on unintended bias and fairness. So what are the unintended consequences of a system? The following one, privacy. This is, of course, of high importance to us all, but what is the ecosystem around data protection in the AI system? Explainability. How do AI black boxes work? So this is about transparency. The next, accountability. Humans in the loop. What is the human oversight in our AI systems? This is crucial. Transparency, again, they are interrelated. Users should be informed when they interact with AI and understand what the outcomes of these systems mean to them. The next, security. again, closely related with privacy. Safety of AI should be tested and assured across that life cycle. And finally.
Yeah, so I guess I'll take it over from this point. So we just want to talk about a bit of, kind of news related, how they are related to the trusted AI principles. So you guys probably have heard like Uber was sued by its drivers over automated robo-firings in the UK court. So the UK court actually ruled in favor of the drivers who have allegedly been wrongfully accused of fraudulent activities by the company's algorithm, and they were immediately terminated without a right of appeal. So, this sort of violates a couple of the trusted AI principles, or the principles here, if it's actually adhered to, will actually help. So one thing is, equitability. What is the unintended harms that's caused by your algorithm? Has that been examined throughout the machine learning development process? And can you answer the question, like through kind of reproducibility, that, if someone else used the same data, and then can they produce the same outcome for these drivers? And how are these drivers' information being used? Does this actually violate the GDPR privacy regulations? So these are all the kind of different principles that's at work when it comes to a particular case like this. And next slide. So there's another thing that we can look at. You guys probably all have heard, Facebook were cut off from the internet for a couple of hours a couple of weeks ago. And this caused so much impact, especially on countries that were heavily reliant on doing business over WhatsApp. So these trusted AI principles are not just with AI applications in itself, but also to all the other, tech systems in place. What is the transparency and accountability in the system? You've probably seen this meme of, this is Mark Zuckerberg trying to figure out, standing in front of a box, like which line to plug, like who to blame here? And can you explain actually what happened? And what is the robustness of your system that billions of people actually rely on? So these are all questions that they really need to be examined when the system is developed and continuously being monitored. So yeah, I think that's it for us.
Sri, do you want to share your slides, or do you want me to just carry on?
Actually, let me share my slides here.
Go ahead. Go ahead. I'll stop sharing. Go ahead, Sri.
Give me 1 second. Can you see my slides?
Yes.
Okay, perfect. So thank you again for the opportunity to meet with you all, and also for people I don't know, hello again. My name is Sri Krishnamurthy from Quant University. I'm always, very intrigued with the ways in which AI and machine learning is applied in various domains. And I primarily come from the financial services domain, where we work with a lot of data, but we also have the fiduciary responsibility to make sure that we handle the assets which our customers entrust to the financial industry in a responsible way. So responsibility is something that the financial industry has taken seriously for a really long time, with functions like model risk management, which are kind of ingrained in this whole area in the financial services industry. It becomes something which we always look up to make sure that risk management is a core pillar in the financial industry. With artificial intelligence and machine learning kind of permeating in the financial industry, there's been new concerns about how do we think about trust in the context of all these new models which are out there. So that's the whole goal of why we are designing the Q Sandbox. And today I want to talk about how can we operationalize trustworthy AI in finance. And as we kind of heard about, what are the various core repeats principles, I want to kind of focus on how do we pragmatically make these accessible to end users? Because from a concepts perspective, everybody agrees that these are important. But if you do not have a way of implementing it, then it just becomes something which you look up to, but there's no way you can operationalize it. In fact, the World Economic Forum did a study, and when they thought about ethical principles, and they did some research, they found that there were 175 frameworks out there, 175. And these frameworks are coming from the academic, actors and industry, government entities, nonprofit organizations, and everybody talks about concerns. Everybody talks about the various issues which are out there. But if you don't have a way of pragmatically applying it, we have no way of actually deploying these principles into practice. And that's where we've been working on the Q Sandbox. And we take a three-pronged approach to handle trustworthy AI. One is education. At Quant University, we have been working on educational programs for more than 8 years now. And we work with risk management organizations, we work with large entities, we work with regulators, and we put together programs wherein we can operationalize these core principles into practice. The second core important thing is what we call as the Q Toolbox. If you do not have a governed way of implementing tooling in an industry, it just becomes a challenge on what do you trust. With open source permeating all our operations in today's day and age, it becomes a challenge for large enterprises and small enterprises to think about, well, what is that am I deploying? What is that am I actually using? So we talk about this whole notion of experimentation, and we have the various tools, including open source and enterprise tools, built in the same framework so that you can operationalize and test various aspects. And finally, we want to be able to start from somewhere. And that's where we have put together various templates to let companies think about operationalizing the various themes, and then they can pick and choose the things which are important to them. So let me kind of detail it in a little bit on how Q Sandbox addresses the LFAI repeats principles. First of all, we talked about equitability, and there is a whole discussion about fairness and bias. And if you start looking at the various tools available out there, we're fortunate we are living in a day and age wherein, with a couple of clicks of buttons, you can actually download an entire package and you can try various things out. And we've integrated various fairness and bias tools into the platform. That way, you could bring in your data sets and experiment and figure out whether you are kind of looking at various elements which are important to you, both from a usability perspective, but also looking at various aspects of bias and fairness metrics. And in order to kind of ingrain, because how many of you have actually used these tools? And I did a survey with some of my peers in the industry, and everybody knew about these tools, but they did not know how to apply them. They did not know how to actually contextualize it with the financial services use cases they deal with on a daily basis. They have data for customers, and they make credit risk models. They make fair lending models. They have anomaly detection and fraud detection models, but they did not know how to actually contextualize and pragmatically apply it. So that's where we're creating a whole training catalog to contextualize how do we apply these tools in the industry. And in addition to that, you have to think about how can you operationalize some of these themes in a pragmatic way. And one of the things which we talk about is if you do not have enough data, or if you want private data sets, how do you go about doing it? And we've built out synthesizers and synthetic data generators, which will enable you to try out various things so that when you have aspects of privacy which are important to you, you can basically use APIs to make sure that you're hiding some of the PIs and other information which may be required for the models. And then the third aspect is explainability. And explainability is the proverbial elephant and the blind man's story, wherein people are having their own interpretations of what explainability means. And one of the challenges is that there are so many innovations happening, and you have this whole discretization of white box, black versus black box models, looking at various interpretability measures and explainability measures. But the question is, how do you actually use them? So that's where we're kind of integrating various open source and some enterprise tools to enable people to pick and choose depending on the models they're going to be working with. And then this notion of accountability. When you think about developers working on an entire model life cycle, and you have the auditors or the model risk managers thinking about making sure that it's comprehensively tested before it's deployed, you want to make sure that you track all these aspects. And some of the tools we are building is to enable you to not only accomplish the various goals, but also track them and log them to make sure that you're accountable for all the testing you have done, accountable for all the report generation and the validation you have done. Many times when bad things happen, people start looking at, well, who was responsible for it and what actually happened. So we want to create an environment wherein you can actually try out, but also log various things you're doing so that you can know where your gaps are and potentially address those. And then this notion of transparency is extremely important, because when you talk about developers, I remember the day when I did some model validation for a company, and they basically said, well, I can give you the model to be validated. And I asked, like, how did this come into this particular state? What parameters were used? What data sets were used? This said, like, well, you don't need to worry about it. You just need to worry about the model. In today's day and age, where a model is just a small piece of the entire life cycle, you want to make sure that you have transparency into the entire pipeline, which goes into building out a model. So that's where the importance of data, the environment in which it's going to be deployed, what are the various processes which are happening before the model is actually deployed, how are various assessments done, and what are the various things you need to look at is extremely going to be important. And then finally, security. And this is becoming something extremely important with some of the challenges which are out there, especially with autonomous driving and potentially use of facial recognition or other computer vision tools in a very significant way. The question becomes, how do you make sure that there are no evasion attacks or poisoning attacks? How do you think about the notion of black box versus white box? So you want to make sure that the cybersecurity best principles, which we have been working on for many, many decades, are kind of leveraged to build out frameworks. And that's where we are kind of building out testing frameworks, building upon the adversarial robustness toolbox and many other tools which are there to assist in testing out various machine learning models. And then finally, the development environment. You want to make sure that your models are reproducible. And that's where we focus on Dockerizing all your environments and then making sure that you're leveraging the cloud environment so that you can reproduce these experiments and also track them so that you know where 1.1 was and in what environment was it developed and where it was deployed. And 3 months down the lane, if you want to go back to a particular snapshot, you have access to that particular snapshot. So responsible AI development also means that you want to make sure that you have reproducible products. And the pipelines are extremely important. That's where we contextualize the entire pipeline into a framework so that you can try out the individual pieces, but also daisy chain them and be able to reproduce the entire pipeline rather than just focus on model reproducibility. The robustness aspects, which we kind of talked about, I kind of see robustness in multiple ways. In the robustness of the pipeline, robustness of the actual models themselves, robustness of how these models behave when they are provided with data which was not used for training, and how do you incorporate robustness in the model itself, and how can it potentially prevent potential security attacks, if you will. So there are various themes, and it's an evolving area, but I think it's going to be extremely important to make sure that you factor in robustness in your pipeline. The way we are kind of looking at the world, in case if you have all these ideas and you don't have a way of pragmatically applying them, these are principles which everybody wants to incorporate. And so we are kind of providing a baseline that these are the potential things you could do. And in case you want to operationalize that, you can focus on the key themes and just ask the questions, how do you think about these various themes? And if it's important for you and if it's a part of your policy in your company, or it's a regulation which you need to accomplish, or ethically you want to kind of make sure that you're working towards an environment which is going to be not only developing new assets for your company, but be built in a trustworthy and responsible way, you want to have a baseline. And the Q Sandbox provides a way of sandboxing it and trying it out before you can actually deploy things into production. So happy to answer any questions, and I will stop here. Thank you for the opportunity again.
Thank you, Sri. So any question to Sri before we move on to the next presentation? So I think there's no question for you, maybe after. So feel free to comment on the chat, and Sri will answer to you after. So I think we can go to the next presentation, Suzanne.
Right, so it's Animesh. Are you ready, Animesh? I think you wanted to share, right?
Yeah, I think that will be easier.
Okay, go ahead. Yeah.
It's early morning here in California, so the light is, hopefully you can see me. Hi to everyone. My name is Animesh. I'm the CTO for Watson AI and ML Open Tech. And I think a lot of great presentations so far, coming to the point, establishing why we need these principles as pillars, and then how can we start applying them with the framework which she talked about. And now we are going to talk about what are the tools and technologies which we are essentially also incubating, building, and proliferating in the Linux Foundation AI and data itself as part of implementing and pragmatizing and putting these principles in practice, right? So one of the things, like and just I work for IBM, but one of the things, right, which IBM has always done in general is working and also focusing along with the business aspects of it. Obviously we are a commercial business, but doing things and building things, right, which are in general for social good. There were around more than 5,000 IBMers working on the moon mission with NASA. There was IBM has invested a lot in genomic research. There has been a lot of investment in climate change via the call for code, where we are working with United Nations and others. And this as an initiative, our efforts on the trusted AI, we see in a similar vein, where it's AI for social good and responsible AI. So when we look at these principles, right, here we are going to go and talk about some of the tools which originated in IBM research, which we then moved in open source, and finally we had it join Linux Foundation AI and data, because that's where it made sense for these tools to be implemented and used in a truly open and trusted manner. So for example, when we talk about around the security, robustness, and privacy aspects of it, now a field which is of highly relevance today. I mean, if we have all seen the amount of ransomware attacks which have gone through over the course of last year, specifically, as the pandemic peaked, so did the ransomware attacks, right? And there is an increased security vector, and we are all aware, more and more focus is being built and put on how to make sure that the technology environments which you are putting up are secure. In fact, there was a meeting at White House around, I think, a couple of months ago. Our CEO, Arvind Krishna, he was there as well, along with a lot of other industry leaders, working with Joe Biden and others in terms of crafting a very comprehensive agenda. Now, this is the larger security risk, and when you just look at it in the context of AI, right, there are surveys which are finding the awareness of risk is low, or there is a low understanding of what AI security means, which is then translating to the security posture being close to zero, right? And part of the reason is machine learning models which are being deployed in production. As such, there is a new attack surface which is still being understood, right? And a lot of the application leaders who are rolling out these models in production, right, they must anticipate and prepare to mitigate risks which come with deploying these models in production, right? And these what kind of attacks could be automated and executed on top of these models. So the other part of it is it's not only something which is becoming a necessity from the perspective of thou shalt do it from a security posture, but also because it's also, if you look at it, becoming a legal imperative, right? We all are aware of GDPR, right? Now, one of the provisions of GDPR, if you relate it back, is essentially that, you can actually work around the models, right? And you do model inversion or a membership inference attacks, which can then, trace back. And there are papers, research papers being published on that, you can trace back the data set or, the semblance of data sets on which the models were trained. Now, there is a right, which is, right to be forgotten. And if people can actually, trace back from the deployed models, the data set or data set samples, then, that essentially is being violated, and that in general, in principle, is violating the Gdpr principle. So as I said, it's not only now required because of all these security attacks happening, but also because, there will be legal, even existing legal provisions actually will force you to make sure that, you are paying strong attention to it. Now, so very simple way to understand, and this is, one of the things when we launched this around, I would say 2.5 years ago, this resonates very clearly, what is happening, how you can fool a model, and what can be the consequences. For example, in this case, right, the stop signs, right, they can be perturbed, or over a course of time, because of the wear and tear of weather, they are perturbed. But, when you look at self-driving cars, the consequences can be disastrous if the car itself doesn't identify it. Now, that was a scenario which was coined in research papers and in academia. But if you see, that's actually started happening in the real world, right? So there was a case in which, there were real world adversarial patches, right, for evasion attack on cause, in which, a lot of the autonomous vehicles led to damage and injury because of that, right? So we are seeing, case after case where, the samples and the cases which were created in academia as a reference, as a sample point, are becoming real in real world. And these are the scenarios, right, which you are seeing what is happening currently around all of us. So, there are different kinds of attacks, right? Evasion, poisoning, extraction, inference. Now, if you have black box models which are deployed, for the most part, right, you are essentially trying to generate adversarial inputs and sending inference requests to your models and trying to fool the model, right? A lot of these attacks are happening. Now, poisoning attacks, where there is a backdoor which is there to the data, and the attacker is then able to exploit that backdoor later. And then, there are attacks like extraction and inference, where you can steal a proprietary model or learn information on private data. So our tool, Adversarial Robustness Toolbox, which is, a Linux Foundation AI and data project, essentially, operates in this. It provides support to detect adversarial attacks against all kinds of models, whether it's TensorFlow, PyTorch, Keras, MXNet, scikit-learn, XGBoost, and on all kinds of data, right? So whether it's tabular data, image data, audio, and video. So it provides you the capabilities to not only simulate and generate adversarial inputs and check whether the model are vulnerable to adversarial attacks, but it also gives you a lot of mitigation algorithms. So if your models are found to be vulnerable to adversarial attacks, you can leverage mitigation algorithms to actually make sure, you can defend against adversarial attacks. And the tool is being used heavily, right? It's not only, if you see the amount of adopters, right, we have derivatives being launched on it, right? So for example, Microsoft has launched a tool called Counterfeit, which runs on top of it. There is Armory, which is from 260 Labs, which runs on top of it. And there are various other adopters, right? Like General Motors, the Mitre Corporation, Intel, who are actually working in terms of, contributing to the tool, using the tool, or building, more user-friendly, more advanced security tooling on top of ART, right? So very, very popular project in the current LFAI and data community around AI security. And in fact, we have had a long and lasting partnership with DARPA, which is the US Defense Research Agency, if you're aware of. And they have been working very heavily with us in terms of ensuring that, the kind of attacks they are looking at, whether it's physical attacks, poisoning attacks, or digital attacks, how they can leverage a tool like this. In addition to the tools I also talked about, right, to actually, create that whole security posture in the defense around AI adversarial robustness. Okay, so we talked about, the principles around security, etc. And now, we go into some of the other RAP's principles, which are around transparency, equitability, accountability, right? And when you talk about fairness, now again, this is something, one of those areas, right, which when we started around, more than a couple of years ago, there were scenarios and samples, right, which were put out, right? For example, since 2008, right, there was this county, and there is this county in Florida called Broward County, right, which assigns a risk score using an algorithm to criminals in terms of, their likelihood of reoffending. And, as part of the investigation, what was found out, right, that it falsely flagged Black defendants, twice the rate at which, what it was doing to other races. And that became a big problem. And there were cases after cases. It was not one single case. For example, in this case, what you see is, Vernon is classified as a low risk, right? And Brisha is classified as a high risk, and she is given a risk score of 8. Now, if you look at what they have done previously, right, Vernon actually has 2 armed robberies, 1 attempted armed robbery. And when you look at Brisha, right, it's 4 juvenile misdemeanors, right? So obviously, the algorithm was heavily biased towards non-Caucasian races, right? I mean, it in a sense, like, it was doing this at an alarming rate. And this is a case of, real world bias surfacing into the algorithms. The other part is, like, as we rolled out, some scenarios and we started discussing this, one of the samples and examples which we put out was essentially bias in healthcare, right? Now, this is, again, there were a couple of sample notebooks which we published and which actually showed, how you can detect bias if it is in the healthcare scenario, and then, how you can mitigate it, right? So this was all demo, all scenarios. And then a year later, there was a news, right, in Wall Street Journal, which essentially found out that it was really the case in real world, where essentially, Black patients were less likely than white patients to get extra medical help, right? So as I mentioned, like, cases after cases, what we are finding is that, the hypothesis we had and the scenarios we were putting out are actually, happening in real world, right? They are becoming, or they are surfacing, even if they were not surfaced at that particular point in time, they're surfacing, to be true. So to handle this, we launched a toolkit called AI Fairness 360, which is an open source library to detect and remove bias in machine learning models, right? Again, the focus is on both detect and mitigate, right? So there are various metrics on which you can detect whether, a data set or a model is supposed to be biased or not. And then it gives you algorithms, right, to mitigate them. So it works around, throughout the AI life cycle, right? So you can, what we call the different phases of it, which is, pre-processor, when you are actually, working on the data side or in the model itself, or, once the models are deployed and you don't have access and you're treating the models as black box models, right? So AI Fairness 360 works across the AI lifecycle, and you can use it to detect and mitigate bias across the AI lifecycle. So there are 70 plus metrics using which you can detect bias. A lot of these, mathematical algorithms and equations, if you go to AI360.myblumix.net, you can see that they are being, explained in terms of how we are actually using these metrics. But depending on your scenario, you can select the metrics. And then once you are found, and once you find that there is a bias in your data set or your model, you can use different mitigation algorithms. So there are 10 mitigation algorithms at this particular point in time. Some of them are very simple to understand. For example, reweighing, right? If you do find a sample which, for example, in the context of the criminal database, which I talked about, right, which was falsely classifying Black defendants, we found that, the amount, and rightly so, because, the amount of samples for that particular race were too high, right? And that's why the models trained on it, or the algorithms which were working on it, right, very skewed towards it. So you can reweigh, give more weightage to the underrepresented samples, right? And there are different algorithms like this which you can use. Okay, so we talked about security and robustness. We talked about equitability and fairness and transparency. And last, let's go to and talk about, some of these features around explainability, right, as the strong pillar. But, with explainability, the side pillars, right, which become very important are, transparency. And the reason you want to explain is because, hey, you want to be accountable, right? You are not shrugging off the accountability. If I'm making a decision to admit someone to a university, or if I'm making a decision whether your loan gets approved or not, I'd better explain why I'm making that decision. And, if that decision is not right, I better be held accountable, right? So these go hand in hand. So essentially, when you look at the concept of explainability, right, it goes at different levels, right? Obviously, the most impacted are the end users or the customers, right? People who are impacted directly by the decision of a model, right? Why did you recommend this treatment? Why was my loan denied? Why am I not admitted to the university? Right now, they are the most impacted, and they definitely should be explained why the decision is being made, whether it's for or against. Then there are people in the middle, right, which is the government regulators or the compliance folks, right, who need to make sure that over a period of time and over a sample of records, the models are predicting in a certain guarded way, and they're not being, drifting, or they're not producing random results, or the results are not being biased, right? So there is this authority in the middle for auditability perspective, right, which needs to make sure, and in a lot of cases, there is the human in the loop, right, which has to also look at a particular prediction and say whether it's good and should I allow it to go through or not. And last but not the least, the developers, right, because there is a lot of transfer learning models being built, where essentially, the base model is being built somewhere else. You're getting those models and you're further retraining them. And to do that, you want to make sure that, the models itself, which are coming to you for further retraining for a particular industry, they are being, explained, etc. So for that, we launched a toolkit called AI Explainability 360, again, a Linux Foundation AI and data project, right? And which includes around 3 classes of algorithms around explainability, whether it's local post hoc, global post hoc, or directly interpretable explainers. And I'll explain a bit about what I mean by some of these terms if they're not clear. And you can hit this website and go ahead and try it, right? So it's essentially, one of the most comprehensive open source toolkit, which is available currently for explaining ML models and data. There are 8 innovative algorithms, right, which came out of IBM research itself. There are 2 from scientific community. Plus, in addition, it also provides you an interface on top of other very open source popular projects like Lime and SHAP, right? So there is this one single comprehensive entry point into the explainability, and then explainability for all the different actors we talked about, right? Whether it's a data scientist or, the auditors and the regulators in between, or, finally the end consumer or the customer, which is impacted by these decisions. Okay, so, and when I say comprehensive, it's not only comprehensive in the set of, the amount of algorithms it can support, it's comprehensive in the context of the life cycle itself, right? So it can generate explanations on data sets, not only on data sets samples, but also on data set features, right? So it can look at data set samples and generate explanations. It can look at data set features and generate explanations. Similarly, when you go towards a model, it can generate both local explanation and global explanation. Now, a local explanation is essentially, in the context of a particular transaction, this model predicted this, right? Now explain this. Global explanation is in the context of multiple transactions or multiple predictions. This model predicted these outputs over a period of time, explain the behavior of the model, right? So it can generate at both the levels, right? And the part is, right, you can also not only generate explanations at both these levels. In the case of model, you can also train surrogate model, right? So in case of black box model, right? So when you're generating explanation for black box models where you don't actually have access to the code, for example, it's a very complex deep learning model, right? It gives you algorithms to actually train surrogate models on top of it. Okay. So very quickly, summarizing this, right? We talked about these 3 projects, which are part of Linux Foundation, AI and data being incubated there, right? And all these projects are being extensively used across enterprises. Some of the largest banks, largest retailers, in US and across the globe are using this projects in terms of, and this is actually principles and practice, how this is being applied. And if you're more interested in, some of the more practical use cases, for example, how the financial industry is using it or how the retail industry is using it, definitely reach out to me and we can share some of that information. But we also, share periodically some of this information in the Linux Foundation AI Trusted AI calls. which happened on the last Thursday of the month, right? If you happen to join.
Thank you, Animesh. You have a question about AIF 260 tool. So Sama Mohamed is asking to what extent this tool could be used to mitigate AI bias. He says that some cases require different definition of fairness. How does the tool take that into account?
So obviously, like, so there are parts of it, like, how you define fairness. Like, so there are 70 plus metrics, and that's why you see that number is so huge, which is 70 plus, right? Like how you will detect bias, or what will you classify as bias is very subjective. Also, varies from region to region. There is also the concept of individual fairness versus a group fairness. What might be fair to an individual might not be fair to a group, right? So and what might be fair to a group might not be fair to an individual, right? So there are a lot of these concepts. And so if you go to that website, af360.mybromix.net, you'll see a lot of these 70 plus metrics you can use and select based on your criteria to detect bias. Now, to mitigate, as you ask, right, there are 10 algorithms which are there. Now, one of the things which I do want to highlight is, by no means these things are, done and hardened, right? One of the reasons why we move these tools in open source, and also the fact that we moved in an open governance. So open source is not enough under Linux Foundation AI and data, so that there is a neutral body which is overseeing this tool. There is a neutral licensing model and there is already, contributions which come from academia, from universities. There are contributions which come from different enterprises, right? So this is not a limited list, right? So if you, as a contributor, find that from the 70 plus metrics or the 10 mitigation algorithms is not something which is fitting your definition, you can contribute, more individual metrics, and these are very pluggable to define bias, and then also, algorithms to mitigate bias. So hopefully, that answers the question. If you need deeper detail, how to actually contribute either the metrics or the algorithms, right? We can have, a follow-on session or, follow-on conversation on that.
Yeah, you have two additional questions, but we are going to go there quickly because you still have an additional presentation to do. So Jujube, she asked if we require users to submit only information that is not personally identifiable, does that suffice as a preliminary safeguard for the data? And we have another question which is quite close, in fact, at the end, which is, let me check, sorry for that. Are there ways where you mitigate bias? It's a question from Brian. Are there ways where you mitigate bias for regression problems or even multi-class classification problems? He says the example given seem binary classification problems.
I'll have to refer to you, I think, on the second. So what was the first one?
The first one was essentially to ask if you ask people to refrain from communicating their personal data. Is it enough to ensure the security, in fact?
Like when they say if you ask people to, obviously, I mean, so there are two parts. Like, I mean, that's a practice which is different than the tool itself. Like, what data set.
Yeah, it's different. I can tell for myself, if you ask people to restrain to communicate personal data, it's not enough to ensure security, in fact. It's not enough, but you can use tools in order to, let's say, mitigate the risk. But maybe the question was more generic than specifically to Animesh. So do not hesitate if I was wrong.
Yeah, I think it was a generic question, and in general, like, and when you talk about in the context of using these tools, like typically these tools are something you take and use on your own data set. We are not asking for any data sets, right? And so that should be very clear. Like, these are open source projects, Python libraries. You install and run it on your own infrastructure, on your own machine, and then point to your own data, right? Whether you want to detect bias in your data, whether you want to, detect whether your models are vulnerable to adversarial attacks, right? So it works. Now, how do you actually, what are the governance policies inside your organization to collect that data and to make sure that data is anonymized and you're not storing any security sensitive information? That remains your organization policy. There is no So yeah, these toolkits are not specific, and all the samples which are out there, they're definitely anonymized, right? So yes, there are samples around, some of the real world cases I talked about, for example, the Bovard-Conti scenario, but all these sample data sets, they have been anonymized, right? So you won't find any personal information or sensitive personal information into them. As for the second question, right? Definitely, I mean, so, I represent IBM Research. It would be best if you can send me an email and I can connect you with a research person from IBM, right, to actually, answer that on that particular point, right? Whether it's for binary classification only, or there are other types of classifiers which we support.
Yeah, thank you, Animesh. We will anyway answer to any additional question after the webinar if needed. So you can go to the next trusted AI and MLSops.
I need to finish quickly. Okay, so now we talk about in the context of MLOps, and for folks who don't or probably you heard enough about the MLOps as a term, right? Essentially, think of it as an initiative to bring data scientists or the folks who are creating these assets for machine learning and AI lifecycle, and the folks who are actually now deploying these assets in machine learning and AI lifecycle, or governing your data sets, right? So the production side and the development side together. So create a set of tools and technologies which can bring these two streams together. That's what MLOps refers to, right? And one of the toolkits which we launched very recently, which Linux Foundation AI and IBM launched, is called Machine Learning Exchange, which is essentially a data and AI assets catalog and execution engine. So you find, data sets, models, pipelines, pipeline components, right? And for example, and these are all trusted in a sense that you can trace the lineage. So if there are data sets, we publish and follow very strong, rigorous guidelines like CDLA, which is a Linux Foundation AI and data license in terms of how data sets should be licensed. We publish a very strong lineage in terms of where the data sets are coming from, what was modified, etc. Right. So that's the rigorous process which is followed as part of before surfacing any data set there, and similarly in the case of models and others, right? So you can go and look for some of these assets there, and specifically a couple of things which we are doing in the larger community are also around, if we do need to insert some of these toolkits in the larger MLOps system, whether it's to detect bias and mitigate bias, or generate explanations as part of the AI lifecycle. How can you leverage as part of the pipelines, right? So we have provided some pipelines as part of the machine learning exchange toolkit, right, which you can use. For example, this is a trusted AI pipeline, which essentially you can download, or if you're running your own instance of the machine learning exchange, you can actually launch this pipeline. And what this pipeline does is that it can actually work on your data set and models, right, and then find out if there is generate metrics around whether your models are vulnerable to adversarial attacks, or it can generate metrics around if the models have bias in them. So you can actually launch and generate those metrics and get a response from this. As you can see, right, this is essentially running after training, where we are running both the checks around fairness and adversarial robustness, and the logs are telling us the output in this particular context. Okay, and not only this, you can do much more advanced. So even if the tools which you have are not in LFAI data, you can do things like outlier detection, drift detection, anomaly detection, right? So there are a lot more advanced metrics you can generate on your models using these pipelines, right? So definitely, if that's an information you need, reach out to us how you can leverage some of these pipelines to do more advanced, metrics generation. And then the other part is like, once your models are deployed in production, how you can check for these different metrics, right? So if they're deployed in production, so there is a very, very popular project in a community called KServe, formerly known as KF Serving. So these toolkits are now integrated as part of the KServe around fairness, explainability, and adversarial robustness toolbox, and they help you, generate metrics once your models are deployed. And to do that, we essentially behind the scenes use payload logging, where we essentially are collecting the model, the requests which are coming to model, and the responses which are going from the model, and then generating these advanced metrics on top of it, right? So the metrics, as I talked about for the LFAI projects, but more advanced metrics as well, like outlier, concept drift, and other things, right? And we are following standards like CNCF Cloud Events Protocol as we are collecting these input and output, right? So there is now all these tools are making their way into these MLOps systems. So they're available in the machine learning exchange pipelines. You can use it with Kubeflow pipelines, and they're also now available with KServe, which is a machine learning model inferencing platform available. So please reach out to us if you need more information. With that, I'll call it today and pass it on to the next one to conclude. And
yeah, thank you, Animesh. I just forgot to tell you that Alok was going to present some slides. So Alok. Is he connected, Suzanne? Sorry, just a few minutes because I thought that I was connected.
Shall we just go through Haluk's slide?
Yeah, I think that I thought that he was supposed to join. He's not connected.
I don't think so, but that's okay. We can just
go through them. Okay.
Yeah, let's just quickly explain the slide and move on. That's okay.
Okay.
Here we
so
go.
I will let you do it, Suzanne, if you don't mind.
Oh yeah, no, that's fine.
Just
that's
remember
fine. Yep.
we have 2 minutes before the conclusion, so
okay,
we can go quickly.
Yep.
Thanks.
All right. So what's happening is that Haluk Demirkan is actually working on some education materials to explain what the principles are and how they can be applied. And he's working with edX for that. I've put in the chat that you can join the mailing list for the Trusted AI Committee, and we will be working on the education with Haluk there. I think that's a reasonable summary of what's happening. And so now it's Francois, right?
Yes, it's Francois who will conclude and end this webinar. Francois, the floor is yours.
Yes, thank you. First of all, thank you to all the contributors for this sharing, very dense and rich. I am François Jezequiel from Orange, member of the LFAI and Data Governing Board as a representative of the general members. And during this session, I've captured some keywords that demonstrate that the principles are really already in action. So principle we have defined together are already in action. First, operationalizing, experimentation, contextualization, multi-dimension for principles. We heard also life cycle, MLOps, and finally this set of open source tooling for trusted AI. At the end, so there is also this education intention we have. So we want to work on that more intensively. We have seen also that there is some really real implementation of AI systems with trusted AI approach in different kind of business. Well, I've seen the example of finance, of cyber security, for instance. So you see that it's already it's in place, but we have a role to play. Why? Because I think that trust, if you come back to the definition, trust is by essence a belief. It's a belief in a system here, but it's a belief in person, in human being. And it has to be maintained all along the time. And I love this quote made by Animesh from Watson CEO. So I think it's a very good example and inspiring quote about what we have to do in the era of AI. Trust in AI has to become a no-brainer for all users and all the usages of AI system. So maybe it looks like an incantation, but it is not. I think our challenge is, as we have seen, first of all, to bring and to build a framework that helps this achievement. It's at the same time a combination of all these principles we have defined, which can be seen as a backbone, and then the tools and techniques. But above all, it's also human intelligence. So in addition, I think we have to accept that it can be, we may have defects. Zero defect AI systems are probably not part of this world. But so our challenge is really to bring a dynamic approach that builds trusty solutions and enables to keep the trust all along the time. So as a conclusion, I would like to invite you to help us to spread this repeats principle. So repeats, it's like a buzzword now for us. It has to become a buzzword in the community and also in the industry. It can be through education materials. It can be also to any sort of contribution. So feel free to join this initiative within the LFAI and data. We need you to evangelize around all these principles and the tools and techniques. So thanks to all of you. Just in time.
Yeah, that's great. Thank you, Francois. Thank you all for presenting. It was really appreciated. I hope that you all enjoyed this.
You're muted.
Evening or day or morning.
And so maybe we did not hear you, Swed, you were muted.
Oh, sorry. So I hope you are hearing me. So thanks a lot to everyone. We hope that you enjoyed this webinar, and thanks to all the participants and the presenters, because we really appreciate what you've done so far. So do not hesitate to join us.
And in addition, a special thanks to Suzanne, who is really our orchestrator in this group. So thanks, Suzanne, for all your work and the energy you put in.
Yeah, exactly. Thanks a lot. Bye-bye. Have a nice day or evening.